So what happens when we divide indices with the same base? If we considered the expression 6 to the power of 5 divided by 6 squared, we could rewrite this as a fraction in expanded form of 5 sixes across the top here, and then 2 sixes along the bottom. Now the reason why we put it into fractional form is when we have the same number top and bottom, when we're simplifying fractions, then we can remove those or set them to 1. So you can see each time we have a 6 matching number top and bottom, we can cross it out and replace them with 1s, which means we've got 6 times 6 times 6 times 1 all over 1 times 1. So if we simplify that, we can see we've got 6 times 6 times 6 over 1, which is the same as 6 cubed. Now, if we look at what we started with, our original two terms had indices of 5 and 2. So it was 6 to the power of 5 divided by 6 to the power of 2. And our final result we got was 6 to the power of 3. So again, you can see that there's a relationship there. And if I've got 5 and 2 to give us an answer of 3, we can see that we have to minus the 2 from the 5. So when we are dividing indices with the same base, what we're going to do is we are going to subtract the number with the index that we're dividing by from the index that we're dividing. So in general form, what that means is we have a to the power of m divided by a to the power of n. Well, that's equal to a to the power of m minus n. Now, the reason why we put it into fractional form is it makes it a lot easier to cross out those common factors originally, but once we have that index law, we can jump straight to it. So we've got, in our examples, 8 to the power of 5 divided by 8 to the power of 3. So again, as we did in the first one, if we write this in expanded form, we'll have 8 times 8 times 8 times 8 times 8 all over 8 times 8 times 8. Now we can cross out wherever we have the same top and bottom. And we're left with 8 times 8 over 1, which means we have got 8 squared. So that's doing it the long way, where we are looking at using that expanded form. If we use our index laws, we can just go 8 to the power of 5 divided by 8 to the power of 3. We have the same base, so we have 8 to the power of 5 minus 3, which is equal to 8 squared. You can see, again, it's a much quicker way to do that. Now let's look at our next example. We have got 10 to the power of 9 divided by 10. Again, what that means is we have a little 1 there. So we have got 10 to the power of 9 divided by 10 to the power of 1. So we've got 10 to the power of 9 minus 1, which is going to be 10 to the power of 8. Doesn't matter if we use prime numerals, because remember, they're just numbers. So we've got the same base again of x. So if I've got x to the power of 7 divided by x to the power of 5, we have got x to the power of 7 minus 5, which gives us x squared. So now, if we look at D, now we're starting to look at when we've got coefficients involved. It does not matter, it does not change anything. We are going to do exactly the same as what we did before. So we're going to start by looking at how we can simplify our numbers there. So we've got 4 over 20. Now 20 has a factor which is 4, so we can simplify this to become 1 over 5. And now we're going to look at our x's. And we have got 8 divided by, well, 8, x to the power of 8 divided by x to the power of 3. So we've got 8 minus 3, which gives us 5. So our answer is 1/5 x to the power of 5, or we could rewrite that as the one fraction being multiplying that of x over 1 gives us x to the power of 5 over 5. Now, looking at our final example here, we just need to work through it, breaking it into the different components. So let's start with our numbers, and we have got 30 divided by 6, which gives us the answer of 5. We are now going to look at our x's, and we've got 5 and 3 there. So we've got x 5 minus 3. And now we're going to look at our y's, which is going to be 4 minus 1. So we're left with 5, x to the power of 2, y to the power of 3. So you can see these multiplication and division laws with indices make it very quick to do these processes. So remember, if we are multiplying, a to the power of m times a to the power of n is equal to a to the power of m plus n. And if we're dividing, a to the power of m divided by a to the power of n means we're going to subtract the second index from the first. So have a go at the work that's been set for you, and remember, if you've got any questions, ask your teacher.